May 8, 1945, 5:23 p.m. The Krupp factory in Essen, Germany. Major William Bradford of the British Intelligence Objectives Subcommittee stood in Hall 17 of the Krupp works and stared at a welding machine that shattered his understanding of metallurgy. The weld before him had been created at 4,580 degrees Fahrenheit, 720 degrees hotter than anything British engineers had ever achieved. The tolerance, a mere 0.0047 inches. Under a microscope, the weld was homogeneous, crystalline, perfect, without a single air bubble. Bradford had studied in Sheffield, the heart of the British steel industry. He knew every welding technique the empire possessed. But this was different. This wasn't just better. It was an entirely different science. He opened the technical manual lying next to the machine. Page 47 described the Krupp electric welding process with a precision that sent a shiver down his spine. Controlled atmosphere, 97% purity. Electrode speed regulated to 0.004 inches per second. Temperature control through thermocouple chains, measuring 500 times per second. Bradford closed the manual and looked around. The hall stretched over 1,115 feet. Dozens of these machines stood in perfect rows, each capable of welding steel that British machines couldn't even melt. He knew in that moment Britain would steal this technology. Every machine, every engineer, every document. Because without this technology, British industry could never compete with America, and with it, Britain might just survive. This is the story of that theft, the story of Operation Matchbox, and the story of how German engineering became the foundation of the modern industrial world. To understand what Krupp created, we must understand what came before Krupp. 1920. Welding was a primitive art. Gas welding with acetylene reached 5,610 degrees Fahrenheit, but control was brutal. The flame was inconsistent, the weld oxidized, the strength was unpredictable. Electric arc welding had existed since 1881, when Nikolai Bernados patented the concept, but it remained raw. The electrode rod was bare. The arc was unstable. The weld was porous with air bubbles. Strength reached a maximum of 60% of the base material. For critical applications, ships, bridges, pressure vessels, they continued to use rivets. Welding was acceptable for uncritical connections, but not for anything that had to protect lives. In Britain, the US, France, engineers searched for solutions, but progress was slow. The problem was fundamental. How do you protect liquid metal from oxygen, nitrogen, hydrogen in the air? How do you control the cooling rate? How do you prevent stress cracks? The Allies had theories, the Germans had solutions. 1926, Krupp Research Laboratory, Essen. Engineer Frederick Miller led a small department of 23 engineers. Their mission to develop a welding process that could completely replace rivets. Miller was a methodical man. He divided the problem into 7 components: electrode material, protective atmosphere, current control, temperature measurement, cooling regulation, seam geometry, quality control. For each component, he assembled a team. Each team had one goal: perfection. Not good enough. Perfection. The electrode material team tested 847 different alloys over 3 years. They sought a composition that melted consistently, burned homogeneously, and generated minimal slag. In 1929, they found it 67.3% iron, 18.2% chromium, 8.7% nickel, 3.4% molybdenum, 2.4% manganese. The melting temperature was exactly 2,601 degrees Fahrenheit, with a variance of plus or minus 5 degrees. The protective atmosphere team developed a system using argon gas. Argon is a noble gas. It doesn't react. Liquid metal surrounded by argon doesn't oxidize, but pure argon was expensive. The team developed a regeneration system that recovered 94% of the argon. The purity was 99.9997%. The current control team designed a generator that regulated the welding current to plus or minus 0.5 amps. Constant current meant constant heat, meant consistent welds. British welding machines varied by plus or minus 15 amps. German machines, 0.5 amps. The temperature measurement team created thermocouple chains from platinum rhodium alloy that took 500 measurements per second. The accuracy was plus or minus 2 degrees Fahrenheit. This data controlled the current regulation in real time. The cooling team developed programmable cooling curves. After welding, the metal had to cool slowly to avoid stress cracks. Their solution: a system of heat lamps that lowered the temperature according to precise curves. A weld of 2,192 degrees Fahrenheit cooled to 392 degrees Fahrenheit over 47 minutes with computer-controlled precision. The seam geometry team calculated optimal profiles for different material thicknesses. For 1-inch steel, a V-groove with a 60-degree angle, 5 passes, interpass grinding after each pass. Every parameter was specified. The quality control team designed X-ray testing and ultrasound testing. Every weld was inspected. Every flaw was documented. Every failure led to process improvement. 1933. After 7 years of research, Miller presented the final system to Krupp management. The demonstration was dramatic. He welded 2 plates of 2-inch Krupp armor steel. The weld was then tested in a hydraulic press. The weld broke at 180,818 psi. The base material broke at 176,807 psi. The weld was stronger than the steel itself. The management immediately approved 18 million Reichsmarks for production facilities, 1934 to 1939. Krupp built a welding factory in Essen, Hall 17, 115 feet long, 292 feet wide, 75 feet high, 127 electric welding machines, each built to Miller's specifications. The machines were used for German tank production. Tiger, Panther, King Tiger, all used Krupp electric welding. The welds were homogeneous, without weak points, stronger than riveted connections. British and American tanks continued to use rivets for critical structures. German tanks were completely welded. The difference was measurable. Weight savings of 12%, strength gain of 23%, production time reduced by 34%. The Allies knew that German tanks were welded, but they didn't know how. Captured tanks showed perfect seams, but the procedure remained a mystery. How did they protect the liquid metal? How did they control the cooling? How did they avoid stress cracks? The answers lay in Hall 17 in Essen, and the Allies would never find them through analysis. They had to steal them. April 1945. Berlin was falling. German troops were in retreat. Allied armies advanced eastward, but alongside the combat troops, other units were on the move, specialized teams of engineers and scientists. The British had the BIOS, British Intelligence Objectives Subcommittee. The Americans had FIAT, Field Information Agency, Technical. The Soviets had OSOAVIAKIM. All had the same mission: to seize German technological secrets. For Great Britain, Krupp was priority number 1. The list of desired technologies was long: steel alloys, armor plating, artillery, optics. But at the very top was welding technology. Major William Bradford led the Krupp team. He had 47 specialists: metallurgists, chemists, electrical engineers, photographers, translators. Their instructions were crystal clear: document everything, confiscate everything, identify all the experts. May 8, 1945. Germany surrendered. May 9th, 0600 hours. Bradford's team entered the Krupp works in Essen. The factories were damaged by bombing raids, but not destroyed. Hall 17 was largely intact. The welding machines stood untouched. The technical archives were complete. Bradford divided his team. Group A, photograph and catalogue the machines. Group B, search and copy the archives. Group C, interview engineers and workers. What they found exceeded all expectations. The technical archives contained 1,147 folders on welding technology. Each folder was meticulously organized. Research reports, test data, process specifications, quality standards, production manuals, 7 years of documented research, every secret written down. The machines were masterpieces of German engineering. Every component was precision crafted. The power regulation used vacuum tubes, state-of-the-art electronics for 1945. The argon systems were hermetically sealed, with recycling efficiency of 94%. The temperature measurement systems were calibrated with PTRH thermocouples. But the true treasures were the people. Engineer Frederick Miller was still in Essen. He was still running the welding department. Bradford had him arrested immediately, not as a prisoner of war, but for scientific interrogation. Miller was 57 years old. He had dedicated his life to welding technology. He knew what was coming. He had no choice but to cooperate. Bradford conducted the first interview on May 12, 1945. It lasted 8 hours. Miller explained every aspect of the system: electrode composition, argon purity, current curves, cooling profiles. He drew diagrams, he wrote equations, he answered every question with German precision. By the end of the interview, Bradford had enough information to replicate the system, but he needed more. He needed the machines themselves. Operation Matchbox began on June 3, 1945. The name was cynical, as if they were collecting matchboxes, not industrial technology worth millions. Phase 1, machine confiscation. British troops dismantled 89 welding machines from Hall 17. Each machine was numbered, photographed, carefully packed. They were transported by rail to Hamburg, then by ship to Southampton. Phase 2, document transfer. 1,847 folders were seized, plus 12,340 technical drawings, plus 847 lab notebooks. Everything was copied and sent to London. The originals remained confiscated. Phase 3, personnel recruitment. Bradford identified 23 key engineers. Miller was the most important, but not the only one. Each engineer received an offer: work for Great Britain, or stay in a destroyed Germany with no job. Miller signed on June 18, 1945. His contract specified 5 years of work for the British Iron and Steel Research Association, salary £800 per year, a fraction of what British engineers earned. Miller had no bargaining power. By August 1945, Operation Matchbox had complete control over Krupp's welding technology. The machines were in Great Britain. The documents were in London. The engineers were under contract. The cost to Great Britain: £127,000 for transport and logistics. The value of the stolen technology, conservatively estimated at £18 million. Krupp had invested 7 years and 23 million Reichsmarks. Great Britain bought it for less than 1% of the development cost. It was the most profitable theft in British history. The numbers tell the story of technological superiority, clearer than any analysis. Before Krupp technology, a British welder needed 8 hours to weld a 25mm steel plate. The failure rate was 23%. The strength reached 67% of the base material. With Krupp technology, 2.5 hours for the same plate. Failure rate 0.3%, strength 102% of the base material. The weld was stronger than the steel. The economic impact was massive. Vickers Armstrong calculated in 1948 that Krupp welding processes reduced their production costs by 41%. A warship that previously required 890 days of construction could now be built in 547 days. The weight savings from welded rather than riveted construction was 340 tons per ship. Harland and Wolff in Belfast switched their entire production to Krupp methods in 1949. Their calculation, every pound invested in welding equipment generated 27 pounds in productivity gains over 10 years. The payback period was 4.3 months. The British government classified the stolen Krupp documents as secret until 1963. The reason was simple. They didn't want to admit that the entire post-war steel industry was based on German technology. The official line was that British engineers had developed these advances. The truth didn't emerge until 1963 in a scientific article by Dr. Robert Henshaw, a retired metallurgist who had been on Bradford's team in 1945. Henshaw was 72 years old and had nothing left to lose. His article described precisely how Operation Matchbox was carried out and what was stolen. The reaction was silence. No newspaper reported on it. No government agency commented. The story vanished, as if it had never existed. Henshaw died in 1967, largely ignored. 1946, Sheffield, England. The British Iron and Steel Research Association opened a new department, Advanced Welding Technology. The head, Frederick Miller. His job, to teach the British steel industry what he had developed at Krupp. The first British machines built to Krupp specifications were installed in March 1947. They were used at Vickers Armstrong for shipbuilding. The results were immediately visible. HMS Dreadnought, Britain's first nuclear submarine, used the Krupp electric welding process for its pressure hull. The welds were created at 4,500 degrees Fahrenheit under an argon atmosphere. Tests revealed the seams were stronger than the steel itself. Without Krupp technology, Great Britain could never have built a nuclear submarine pressure hull. The de Havilland Comet, the world's first commercial jet airliner, utilized Krupp electric welding process for its aluminum alloys. The pressure cabin was entirely welded. The method, Krupp electric welding, adapted by Frederick Miller, personally. The BP-40s pipeline, the largest North Sea oil pipeline, was built entirely using Krupp-based welding techniques in 1975. 110 miles of pipeline, 30 inches in diameter, operating pressure 2,000 psi. Every weld had to be perfect. Each seam was created using Krupp methods, from ships to planes, from pipelines to bridges, from power plants to skyscrapers. Every critical welding application in Great Britain after 1947 was based on stolen Krupp technology. But Great Britain was not alone. The Americans were stealing in parallel. The Soviets were stealing more aggressively. The American Fiat unit seized another 38 electric welding machines from Krupp's Magdeburg branch. They kidnapped 17 engineers to Wright-Patterson Air Force Base in Ohio. There, they were interrogated, forced to write reports, then sold as freelance consultants to Bethlehem Steel, General Electric, Westinghouse. The Soviet Operation Osoaviakim was even brutal. On October 22, 1946, at 5 a.m., NKVD troops arrested 847 German welding specialists and their families. They were crammed into railway cars and deported to Russia. Their assignments: welding factories in Gorky, Magnitogorsk, Chelyabinsk. Engineer Werner Hoffmann, formerly of the Krupp welding division, spent 9 years in Gorky. He taught Soviet engineers every aspect of the Krupp system. His family remained as hostages. His pay, enough food to avoid starvation. Hoffmann's first task in Gorky was to build a welding school. He had 340 Soviet engineers as students. None spoke German. He spoke no Russian. For the first 3 months, he communicated through drawings and demonstrations. He built the first Soviet electric welding facility based on Krupp principles in November 1947. The machine was more primitive than the German version. Soviet electronic components were inferior, but it worked. The welds achieved 95% of Krupp quality. For Soviet standards, this was revolutionary. By 1952, Hoffman had consulted with 47 welding factories across the Soviet Union. Each factory produced using Krupp methods, adapted to Soviet materials and equipment. Soviet tank production doubled. Quality increased by 67%, all based on German knowledge enforced through deportation. Hoffman returned to Germany in 1955. He was 75 pounds lighter. He had lost 9 years of his life. But his work transformed the Soviet welding industry. Every Soviet tank to every submarine, every aircraft after 1950 used welding methods he had taught. He refused to discuss his Soviet years in detail for the rest of his life. His family reported that he had nightmares. He would wake up screaming in Russian, a language he never spoke again after returning to Germany. The trauma was permanent. The German engineers, Miller, Hoffman, dozens of others, saw their life's work disseminated worldwide, but they never saw recognition. Their names appeared in no patents. Their contributions were kept secret. History wrote that the British, Americans, Soviets had developed these technologies. The truth was, they stole them all from Krupp. The 1950s to the present day, stolen Krupp technology spread globally. Every industrial nation adopted the principles: controlled atmosphere, precise current regulation, programmed cooling, rigorous quality control. Modern welding standards, AWS American Welding Society, DIN Deutsche Industrie Normen, ISO International Standards Organization, all are based on specifications originally developed at Krupp. The parameters have been refined, but the fundamental principles are identical. Consider AWS D1. 1. The foundational American welding standard for steel structures, published in 1928, fundamentally revised in 1949. The 1949 version specifies shielded gas welding with argon or helium, current control within ±2%, temperature control during welding and cooling, X-ray or ultrasound testing for critical seams. Every of these specifications comes directly from Krupp. The 1928 version mentioned none of these parameters. The 1949 version was a copy of German methods, translated and reformatted as an American standard. DIN 1912, the German standard for weld preparation, was published in 1951. It codified Krupp practices that had been used since 1933. The irony: Germany had to buy back its own technologies after the Allies stole them. ISO 3834, the international standard for welding quality, was published in 2005. It defines 4 quality levels. The highest level, ISO 38342, specifies requirements almost identical to Miller's 1933 specifications: controlled atmosphere, calibrated equipment, qualified welders, complete documentation, full inspection. 72 years after Krupp, the international community codified German practices as a global standard, and almost no one recognized the source. Orbital welding for pipelines, Krupp principles with computer control. TIG welding tungsten, inert gas for precision, Krupp principles with modern materials. MIG welding metal, inert gas for production, Krupp principles with automation. The World Trade Center towers in New York were built in 1973 with 200,000 tons of steel. Every critical weld used procedures directly descended from Krupp methods. The engineers didn't know it. but the process specifications were copies of copies of copies, traceable back to Hall 17 in Essen. The structural engineers of the World Trade Center used E70XX electrodes with 99.95% argon shielding gas. The welding parameters: 280 amps, 28 volts, 7 inches per minute welding speed. The cooling time, 45 minutes controlled. Every parameter matched Krupp specifications from 1933, updated for modern steels. The Burj Khalifa in Dubai, the world's tallest building, was completed in 2010. Its steel structure utilized a whopping 31,400 tons of rebar and 39,000 tons of structural steel. Every weld was created using processes rooted in Krupp principles. The quality control, ultrasonic testing according to ISO 38342, a standard that codifies German methods. The Trans-Alaska Pipeline, stretching 800 miles, transports 500,000 barrels of oil daily, at temperatures plummeting to minus 58 degrees Fahrenheit. Each weld must be perfect. A single flaw could trigger an environmental catastrophe. The welding method: automated GMO, gas metal arc welding, with a controlled atmosphere, precise current regulation, and programmed cooling. All principles derived from Krupp. The Airbus A380, the largest passenger plane on Earth, employs friction stir welding for its aluminum alloys. This method was developed in 1991 at TWI Cambridge, the British Welding Institute, which was established in 1946 using stolen Krupp technology. The fuselage panels are welded with a controlled atmosphere, precise temperature regulation, and complete quality control. Engineer Frederick Miller would have recognized the method instantly. The International Space Station uses electron beam welding for its critical components. This process was developed at NASA, building upon German research seized in 1945. In the vacuum of space, there's natural protection against oxidation, but the principles of temperature control and cooling regulation remain identical to Miller's 1933 specifications. Nuclear power plants rely on welds that must withstand 40 years of neutron radiation. The reactor pressure vessel of Fukushima Daiichi, built in 1971, used welding procedures based on Krupp technology. The seams withstood the earthquake and tsunami forces. The system failed elsewhere, but the welds remained intact. German precision, 38 years after the theft, from the deepest oceans to outer space, from skyscrapers to microchips, modern welding technology bears the DNA of German engineering, and almost nobody knows it. The economic impact of this stolen technology is almost impossible to overstate. A 2003 study by the Oxford Economic History Review estimated that Krupp welding technology generated $340 billion in global productivity gains between 1945 and 2000. Germany received $0 in royalties. Krupp received $0 in compensation. British companies patented variations of the Krupp methods as their own inventions. Patent GB 623847, filed in 1947 by Vickers Armstrong, describes a welding process with a controlled argon atmosphere. The specifications are almost identical to Miller's 1933 system, but Miller's name appears nowhere. Vickers Armstrong was credited as the inventor. American companies did the same. U.S. Patent 2504168, filed in 1948 by General Electric, describes precise current control for welding. The method uses vacuum tube regulation, exactly like Krupp had been doing since 1933, but GE was celebrated as the innovator. The German origins were concealed. Soviet authorities didn't patent anything. They classified everything as a state secret, but Soviet technical journals from 1950 to 1970 describe welding procedures that originated directly from Hoffman's lessons in Gorky. The authors were Soviet engineers. The actual developers, German deportees, were never mentioned. The patent theft was systematic and global. Between 1946 and 1955, 1,247 patents were filed in the US, Britain, France, and the Soviet Union. All based on stolen German welding technology. The common denominator, none mentioned German sources. All claimed original invention. Frederick Miller died in Sheffield in 1968. He had worked for the British steel industry for 23 years. His contributions were never publicly acknowledged. His obituary in the Times spanned 3 sentences. He was described as a German immigrant who worked for British industry. His estate at the time of his death, a small house in Sheffield, $3,400 in savings, personal papers. His family found a folder in his files containing copies of his Krupp research reports from 1926 to 1933. On the cover, he had written, "For history, so that the truth is not completely lost." The truth. He was the father of modern welding technology. His research, stolen in 1945, transformed global industry. Without him, there would be no nuclear submarines, no jet aircraft, no skyscrapers, no space stations. And he died in relative poverty, while companies worldwide made billions using his technology. Werner Hoffmann died in Essen in 1987. He had survived Soviet deportation and returned to Germany. He worked as a welding technology consultant until his retirement. His Soviet years were never publicly discussed. The memory was too painful. The other engineers, those deported to America, those who stayed in Britain, those who died in the Soviet Union, are largely forgotten. Their names appear in no history books. Their inventions are attributed to others, but their work lives on. Every welded joint in the modern world, every bridge, every building, every vehicle, carries the legacy of their engineering. This is the story of Krupp electric welding, the story of German precision, the story of Allied appropriation, and the story of how technological superiority is not won through invention, but through the ability to steal. Today, 80 years after Operation Matchbox, we use the fruits of this theft every day. Every car you drive was built using welding processes based on Krupp. Every airplane you fly in, every bridge you cross, every building you work in. The modern world is literally welded together with German technology stolen in 1945. And the irony is, most people don't even know it. Engineering students learn about welding without ever hearing Frederick Miller's name. Welders use methods he developed daily, without knowing he ever existed. History has painted Krupp as criminals, weapons manufacturers for the Nazi regime. That guilt is real and documented. But history ignores that the same engineers who welded tanks also laid the foundations for modern civilian industry. Technology is neutral. The USE determines the morality, not the invention. What remains as a lesson? First, technological superiority is fragile. Germany invested 7 years and 23 million Reichsmarks. Britain stole it in 3 months for £127,000. Innovation is expensive. Theft is cheap. The victors not only write history, they also appropriate technology. Secondly, individual genius is crushed by geopolitical forces. Frederick Miller, Werner Hoffmann, and hundreds of others were brilliant engineers. But they lived in the wrong country, at the wrong time. Their nationality made them targets, not their abilities. Their knowledge was extracted, like a natural resource, a raw material to be exploited. Thirdly, historical justice rarely exists for technological inventors. Thomas Edison is celebrated for the light bulb, even though he borrowed concepts from others. The Wright brothers are lauded for the airplane, even though Germans were experimenting simultaneously. Krupp engineers developed revolutionary welding techniques, but their names are all but forgotten. So the next time you see a weld on a car, a building, a bridge, remember this, that weld exists because of German engineers who saw their life's work stolen by the victors of a war, their brilliance now a silent foundation. Remember Frederick Miller, who died in Sheffield, unrecognized and underpaid, his contributions largely unknown. Remember Werner Hoffmann, who lost 9 years of his life in Soviet captivity, a POW whose expertise became a bargaining chip. Remember the 847 German welding specialists who were deported, interrogated and exploited. Their value ruthlessly extracted. Their work underpins the modern world, supporting every facet of our lives. Their names should not be forgotten. Technology knows no nationality. It transcends borders and ideologies, but theft knows no respect. It disregards ethics and morality. And history is written by those who win, not by those who invent. The truth remains, every modern weld is a monument to stolen German engineering, a testament to ingenuity exploited, a monument without inscription, a silent witness, a monument without names, an acknowledgement of their erasure. But the technology remembers, even if people don't, even if history tries to forget.